everyone. Welcome to today's video. Today is all about controlling and wiring relays. So I'm going to use two examples here. I've got a pretty new Aqualink RS. It's not mounted, nothing connect to it, pretty much out of the box. And then I've got an independent relay as well. In this video, I'm going to go through essentially how to wire these relays both for 120 and 240 to a clear controller. And again, the main goal of this is if you already have an automation system or if you have something like an intermatic timer cabinet, you can actually order these relays. We'll put the part number here, but they're Omron based relays. I think the whole industry uses them. They're available online anywhere from 20 to 40 bucks depending on where you go. And so you can actually automate your single speed pumps, blowers. You'll need these relays if you have the old lighting systems that click. A lot of equipment still uses these relays. So we're gonna do some examples of both wiring up like the single relay and then how we suggest also like wiring it into an existing cabinet like this. So it'll all be kind of inside today. I don't have like a active system, let's say, but this should be good enough to get you going and have your single speeds, blowers, other things on a relay all hooked up and running with clear. So let's go ahead and get started. Okay, so to get started, there aren't a lot of pieces today, but they are important. In fact, this video probably is one of the most important in making sure you really pay attention to different wires, power supplies, cables, etc. Although the relays are so simple, Clear's got a little bit of a hookup we got to do in order to get this to work. So first of all, we only can use a Clear controller. The Clear controller has three relay spots. They're all labeled aux 1, 2, and 3 down here at the bottom. So there's only 3 spots to support 3 relays at this time. That'll be all right for most of the use cases. In this video too, in order for the relays to work, you also have to use the power supply that Clear sent you. It's 24 volts. Essentially these relays, so again, this is the Omron. It's what Pentair, Jandy, and Hayward uses in their cabinets. It's an Omron relay. Can post the part number, but they're pretty easy to find online. This requires a minimum of 17 volts DC in order to engage the coil. So that's why you won't be able to use the power from like a Hayward pump or off the Aqualink system, because the voltages on those systems are less than 17, typically 10 to 13. So you got to use the 24 volt power supply that's there. And then as well, Clear has these jumpers. So they're 7-foot jumper cables. So we'll see shortly. These jumpers are meant to basically, you'll end up basically plugging a jumper in over here and then running this cable to your existing cabinet or another cabinet. And that's because the Clear box and the Clear controller is not certified for higher voltages. And so that means we can't bring 120, 240 volts into the cabinet. So this is all we'll need today, but it's quite a bit. So let's go ahead and get started. So in general, where I'm going to start is how to wire and set up the Clear controller for relay control in general. And then I'll talk about if you're new to wiring relays. Again, I'm not a licensed electrician, but I'll go through how to wire up the relay for some specific configurations, particularly 120 to 240. Now, I'm assuming, in the application today, you'll either be putting one of these in an Omron, in a cabinet, like in an intermatic cabinet where you had your timers, or maybe you even have an existing older cabinet from Pentair or Jandy where the relays are already there. So your wiring may already be done for you. That'll be helpful. I'll do my best to cover how these work, but first let's go ahead and just get started on the wiring for the Clear controller. So just using what we have, I've got the power supply. We've got that plugged in there. The main thing that you need to pay attention to on the Clear controller is that this jumper here needs to be connected to the power supply as well. So what I'm gonna go ahead and do is I'm gonna go ahead and just double up on these reds, and I'll put the black into ground, and that'll make sure that this power feeds the relay power on these. So let me go ahead and do that now. All right, so I now have the jumper wired in, sharing with ground and power, so I can go ahead and plug this in, boot it up. All right, cool. So now the clear controller is on, so this would be in your cabinet, etc. And so now really the only thing that I'll have to do is just pick the aux port that I want, and you can see these already have ferrules on the end of these, so I can pick, you know, aux 1 and just plug this in here. Again, in general, for all the aux ports, power is on the right, ground is on the left, and so this isn't engaged yet, so if you went over here, we won't hear any clicking because the aux port has not been added to the app, but we can go ahead and do that now. So relatively simple. You just don't want to forget the jumper onto the power to basically draw power from your main power supply, and then all you got to do is have this 7-foot jumper. And yeah, now I'll just show you quickly how to add it in the app, and then we'll go through the tutorial on relay wiring. And adding a relay in our app is really simple. So like normal, you know, on a location, I'm going to go to the settings, devices, add, pool equipment, and I'm going to look for either terminal block. In some versions of the app, it's also called relay, so I can just click that. Now, I'm going to go select the aux 1 where we plugged it in and hit save. So give it a sec here for that equipment to add. Okay. Just give it. All right, and now it's been added there. So as soon as that's there, I can go to equipment and I can see that it's in idle mode. So not a lot I really want to do here to turn it on or off, although I could. Idle just means that it's not engaged or it's not on. So there's two ways that we can turn it on in the app. The most convenient way is probably to go add it to a schedule, which I'll show you, how to do later when we're messing with the relay. But here I could just go, as an example, add the hour right now, add this terminal block, and I could set it to on. That will turn it on. The other easy way to add the relay is actually through a program. So here you'll see the terminal blocks also available for you. We should have probably changed the name, so if you want to do that and make it better, you can come in here and we could change this to say, like let's call this the blower. Save that. Give it a sec. Alright, so all I've done now is taken the relay. I have a little automatic screwdriver, and the polarity tends to not matter on this. It's just DC going through a coil. So as long as we have the clear board hooked up right in the previous step, everything should be good to go. And so I have screwed in the green, which is ground, and red, which is our 24 volts, onto the two sided terminals. Now, those on the Omron are terminal 1 and terminal, looks like 0, 2 and 4 and 6 and 8. That's what we're actually reserving for our higher voltage wires, etc. So with all this hooked up, I've got the app off to the side on my computer. So I'm going to go ahead and I'm just going to put a schedule to turn this on, and we'll hear a little click, hopefully, once this goes through. And if you heard that click, we're good. So let me just go ahead and I'll bring the voltmeter into view here so we can actually see that across this terminal. Yeah, almost 24 volts. And so then if I were to go and just remove this schedule or turn the valve off, this relay off, Now you can see we heard it click and goes off just like that. So it's pretty easy. Again, just the main steps you got to make sure are that jumper needs to be connected to at least 24 volts DC. And then you want to have these relays from Omron available. Again, these are the same one used in the cabinet. So that's why this jumper is actually so long, is that your clear controller should be close to the existing cabinet, and you just run the 7-foot wire over there. You would unhook the current relay connectors from like your Aqualink, tie these in there, and you're pretty much good to go. You just need to know it's connected on the other side. So that's what I'm going to cover here just shortly, is like how the wiring works with these relays, both for 120 and 240. So let me do that next. All right, so in this section, I'm going to show you some wiring on 120 volt hookup. Now, I've just put on this little post-it that, you know, we could be going to a blower, controlling a blower, controlling, let's say, a small pump. So what I've got wired up, and actually before I move any further, I'm doing this for demonstration purposes only. As I said, I'm not a licensed electrician. Before you do any of this, I have a huge word of caution that this is high voltage. It can be very dangerous if you don't turn the breaker off, and if you don't know what you're doing, I wouldn't really proceed. I would really ask an electrician or a company to come help you with this. So I just want to caution that again in the video. However, what I have drawn here on the post-it, so this is how a 120 wiring should work. So I know the colors aren't right and the gauge isn't right. Typically you see black, white, and green for 120. Black is typically hot. I just didn't have a black wire in the shop today. So our yellow is our 120, that's our hot. And then green would be the hot line going to the blower. So in this wiring, when the relay engages, or when the clear controller tells the relay to turn on, we're basically connecting the yellow wire to the green wire. And you can see this side of the terminal block is unused in 120. So normally you would hook up the, from the breaker panel coming in here. This would be going out to like the pump or the blower, and you would already connect your white wire together, and essentially you're just completing the circuit here. So this would be kind of a standard 120 wiring, and basically again, when these turn on, it connects terminal 2 into terminal 4, basically connects these wires here. And so it's pretty straightforward, just kind of flips the switch and engages the 120. All right, and then this would be a standard 240 VAC wiring. Again, colors are off, and normally if you go out and let's say you have an intermatic panel right now, or a timer, an old mechanical one, you're probably going to see brown wires and blue wires, where the brown wires are typically hot. Blue wires can be as well. And so what you're probably going to see actually is something like this close on your intermatic timer or a terminal block. So for 240 wiring, what you typically have is 2 wires of the same color. So I use 2 yellows here. Each one of these by themselves is carrying, 120. But because we have 2 of them, by the time they get to the pump, when you add them together, this would be L1 and L2. They're both hot, so you would get 240 VAC. You then have these 2 green wires, which are actually going to the pump. So the yellow would be coming in from your breaker panel, and then the green would actually be going to the pump. So what happens is when this relay engages, we actually connect this yellow and this green, and we connect this yellow to this green. And so it's all sent, and it all happens at the same time. And this is really important wiring, because if you don't get this wiring right, and let's say things are mixed up, you could accidentally only send one phase of the 120 to the pump, and that would not be good. So this is a proper 240 wiring for your kind of standard bigger single speed pumps, etc. And yeah, so that's all we have for the video today. Thanks.